In this question, we are being asked to find the resultant on force Q3. This is force Q3 and we are being asked to find the resultant on this force, on this charge. Now this charge is experiencing forces due to Q2, due to Q1 and due to Q4. Force Q3 is a positive, charge Q3 is a positive one, charge Q2 is a negative one. Since unlike charges attract, it means that the force of Q3 due to Q2 will be in that direction because these two are attract. So if this force is to be stationary, this force will be pulled in that direction. The force due to Q2 will be pulling this in this direction. The force due to Q1 will be pulling Q3 away because this is positive, that is positive, and since like charges repel, it means they will be parting separate ways. So this will be moving in this direction. And then we have charge Q4. Charge Q4 is also positive. Q3 is also positive. It means along this line, the force due to Q4 will be pushing this downwards. And so with that kind of analysis, we'll end up with the forces on Q3 in these kinds of direction like this. We have force due to Q2 in that direction. We have force due to Q4 moving downwards. And then we have this in this direction. Force due to Q1. So our task is very simple. We are going to find these forces FQ1, FQ4 and FQ2. After finding those forces using Coulomb's law of electrostatics, then we shall find the resultant of these forces, and that will be the resultant force acting on charge Q3. We'll begin finding the force due to Q1. The force acting on Q3 due to Q1, it means we are considering this and that. The charge on Q1 is 2 microcoulombs, the charge on Q3 is 5 microcoulombs. So we begin. FQ1 is going to be equal to Q1 times Q3 divided by 4 pi epsilon naught times r squared. That's going to be, what is Q1? Remember, 1 over 4 pi epsilon naught is 9 times 10 to the power 9. Multiply that by Q1. Q1, if we look here, Q1 is 2 microcoulombs. So it means that our Q1 is 2 microcoulombs. 2 times 10 to the power negative 6. Multiply that by Q3. Our Q3 is 5 microcoulombs. So it is by 5 times 10 to the power negative 6. Divide all this by their separation squared. What is the distance between them? The distance between Q3 and Q1 is 5 centimeters. Converting this to meters is going to be 0.05 meters. So this squared, this is going to give us 0.05 squared. And our force FQ1 is going to become 36 newtons. So we find force acting on Q3 due to Q4. So FQ4 is simply going to be equal to Q3 Q4 over 4 pi epsilon naught r squared. R is the distance between the two charges. That is simply going to become 9 times 10 to the power 9. We said 9 times 10 to the power 9 according to experimental observations is what is equivalent to 1 over 4 pi epsilon naught. Multiply that by Q3. We say, you know that Q3 is 5 microcoulombs and Q4 1 microcoulomb. So continue with our calculation. It's going to be times Q3, which is 5 times 10 to the power negative 6, times Q4, which is 1 microcoulomb, so it's 1 times 10 to the power negative 6. Divide all that by the distance between them. If you look at our diagram, the distance between Q3 and Q1 is 3 centimeters. Converting this to meters is going to be 0.03 meters, and it means that this is divided by 0.03 squared. 0.03 is our value of R. So our answer here will be 50 newtons. So we find the final force that is acting on Q3 due to Q2. That's going to be Q3, Q2, divide that by 4 pi epsilon naught R. That's going to still be 9 times 10 to the power 9 times 5 times 10 times Q3, which is 5 times 10 to the power negative 6, multiply that by Q2. Now Q2 is 3 microcoulombs, so it's going to be 3 times 10 to the power negative 6. Divide all that by their separation. The distance between Q3 and Q2, the distance is 4 centimeters. Converting that to meters is going to give you 0.04 meters, and so it means that this is going to be equal, divide that by 0.04, and this is squared. So our answer here will be 84.4 newtons. That is our force, the force acting on Q3 due to Q2. So now at the end of the day, this is what we have. We are having a charge, a point charge, but that we are calling Q3, and it is having 3 forces acting on it in this kind of manner. It is having a force acting that way, FQ2, which we have found to be 36 newtons. So from this we are going to now resolve these forces along the x-axis and along the y-axis, and then we will be able to get the resultant of the forces. So after the analysis, this is what we have. This is our point charge, Q3. It's here. And it is subject to the forces Q2, which is 84.4 newtons in that direction, Q4, 50 newtons, pulling it in this direction, and 36 newtons, pulling it in that direction. And our task here is to find the resultant force acting on that point. Finding the resultant force acting on that point means that we are going to resolve each of these forces both in the x and in the y. So we shall get the total resolution of forces in the x direction, we get the total resolution of forces in the y direction, and we get the resultant using this formula. So we begin getting the resolution of forces. So we first have to get the resultant force in the x direction, resultant force in the y direction for each force. So we shall get the resultant force for FQ1 plus the resultant force both in x and y direction for FQ2, which is that. Then the resultant in that direction also, FQ4. So we go ahead and say for FQ1, which is this force, resolving it in the x direction, it is FQ1, this force, cosine of theta. How does that come about? If you look at our diagram, we'll try to complete it like this. You find that it's inclined at an angle theta. And this point Q, remember, is at a certain point in our square, as per our question. According to our question, this is 4 centimeters, this is 5 centimeters, this is 3, that is 3 centimeters. So let's transfer this information down here. Here is 4 centimeters. Right here is 3 centimeters. So meaning this is 5 centimeters. According to Pythagoras theorem, this is 5 centimeters, the diagonal. Now this is our angle of inclination, theta. And if you look at this theta, this angle is equivalent to that angle. Those are vertically opposite angles, so this angle is also the same as that. This theta is the same as that. So as we are resolving this FQ in the x direction, So it is FQ1, the cosine of theta, because we are resolving along that. And it is negative because it's on the negative side. So it's negative that. Resolving it in the y direction, we are resolving it along this direction. It is negative, and so it's going to be FQ, that is 36, times the sine of this angle to get the component in the y direction, which is that. Then we go ahead, this is going to be plus FQ2. FQ2 has only the component in the x direction, in the positive x direction, so it is positive 84.4. And in the y direction, this post does not have any component, so that is 0. Plus FQ4. FQ4 has got no component in the x direction, so that's how we have a 0. And then in the y direction, it is negative 50 newtons. So we do the arithmetic, we substitute for those cases here. How do we get cosine of theta? Remember, we said that this theta is the same as that theta, so to getting this cosine of this theta, cosine of theta is going to be equal to opposite over hypotenuse. Opposite of this theta is 3 over hypotenuse, which is 5, so it is going to be 3 over 5. And then the sine of that, the sine of theta is simply going to be adjacent, which is 4 over hypotenuse, which is 5. 4 over 5. And that's how we get the figures for which we substitute for this cos and this sine. So it becomes FQ1 is 36. So it's 36 times that, plus that, and this. So we'll end up with the total resolution of forces in the x direction is 55.6 newtons, and the total in the y direction is 71.6 newtons. So to find the resultant is to simply find, we substitute in the x bar squared plus the y bar squared. Our resultant force is 90.65 newtons. So if our resultant force is 90.65 newtons, it means that our point charge Q3 is like this. This is our point charge Q3. It is in the x direction, it is positive 55.6, so it is acting in that direction. 55.6 newtons. And in the y direction, it is acting in the direction, it is negative 71.6, so that's why it's pointing downwards as 71.6 newtons, because it is negative. So finding the resultant of this, the resultant lies along there. The resultant force, let's call the resultant force R. And it is inclined to the horizontal at a certain angle, we shall call alpha. So getting this resultant is what we are using. We used Pythagoras theorem to get the resultant. 55.6 squared plus 71.6 squared. Because at the end of the day, this is 71.6, the same as this. 71.6. So this squared plus that squared should give us that resultant squared. And that's how we get 90.65 newtons. So after getting the 90.65 newtons, now we seek to find the direction of the resultant force. The resultant force is inclined to the horizontal at a certain angle we have called alpha. So to get that angle alpha, we shall use trigonometry. Tan of alpha, which is that, is going to be equal to opposite. The opposite of this angle is 71.6, which is that. Divide that by adjacent. The adjacent is 55.6, which is that, 55.6. So we shall end up with our alpha as 55.2 degrees. So we shall conclude by saying that the resultant is 90.65 newtons at 55.2 degrees to the horizontal. That brings us to the end of this video. Thank you for tuning in. Please don't forget to comment below and hit that like button. Someone out there may like to watch this tutorial. Don't forget to share. Otherwise, for more videos, simply subscribe to this channel. For Kisembo Academy, this is Arnold Coulomb.